Okay, for our first lesson after spring break, we're going to pick up on the notes where we left off right before vacation, our long vacation. We were working in the second packet in Module 6. It was titled The Rectangular Coordinate System, and we had made it to page 4, and we're at the very bottom of page 4. So we had left off by doing example 3 and 4 above. So we did a little warm up in the last video just to remind you how to graph lines using the table of values or the t-tables. In this example 5, this is like A and B, by the way. I just put one graph because I ran out of room. So generally, if you had this problem on a test, which you will, it will be 2 different graphs, or maybe just one of the 2 will be on there, not 2. So let's do the first one in purple, and we'll do the second one with a different color, just so you can see that those are indeed 2 different problems. So these are our special cases. What you should notice, let's look at example 4 and example 3 at the same time. All the examples we've done up until now, even example 3, had an x and a y in the equation. And look at example 4, it had an x and a y in the equation. But when you get to example 5, you should notice that it does not have both. This first one only has an x, and the second one only has a y. So that right away should send up little warning bells. Oh, this isn't the regular kind of problem. This is a special case problem because it only has one variable. And we're going to learn in just a bit that equations that only have one variable, just x or just y, are either horizontal or vertical. And the letter that is there, the variable, tells you which axis this line passes through. So this is my x-axis. This is my y-axis. This tells me this line passes only through the x-axis, and it passes through at 3. Well, knowing that it's horizontal or vertical, you can go, oh, if it only passes through the x-axis, that means it must be vertical. Likewise, this one, since it only has a y, means it only passes through the y-axis, and it passes through at -2, which means this is going to be a horizontal line. So by the time we take the test next week, you should be able to recognize that anytime a line has only one variable, an equation, that means it's going to be horizontal or vertical, and this tells you which axis it will pass through. So if it only passes through the x-axis at 3, it would have to be a vertical line. If it only passes through the y-axis at -2, it would be horizontal. Usually on these, we don't give a t-table. Sometimes we do, sometimes we don't, but you should be able to sketch them, even if I just gave you an equation. Oh, x equals 3, that would be this vertical line right here. Let me turn off my phone. I forgot I started class, so I need to turn it off. Sorry about that. My last 12-minute video took 45 minutes to load up to YouTube, so I was asking someone for help. I think they're all overloaded from everybody doing the same thing. Okay, so x equals 3 means all the x's in the t-table are going to be 3. And, well, let's just do one at a time. So if all the x's are going to be 3, that means I can pick whatever I want for y, because there's nothing, I can't plug something in and get y. So let's pick 1 negative, a 0, and 1 positive. And again, we knew x was 3 because this is red. X is 3. So all the x values need to be replaced with 3. Y can be anything. I could have picked -100, 0, and +100. I just picked smaller values so that they would fit on the table. So remember, we know the minute we see these that they're either going to be vertical or horizontal. So keep on the lookout for that. So when we go to graph this first one, and I was supposed to use purple. Let me change it so the line matches it. 3, -2, 3, 0, 3, 2. So that's going to be a purple line. 3, -2 would be right there. X is 3, y is 0 would be right here. X is 3, y is 2 would be right here. And sure enough, it gave us a vertical or horizontal line, and in this case it would be vertical. And we knew that because it says it only passes through the x-axis. Horizontal lines only pass through the y. Vertical lines only pass through the x-axis. So just like any other line, you use your straight edge and you draw arrows on both ends. Okay, now let's switch colors and go to the pink line. So this one, and remember, equals, like we learned back in Module 5, is red is. Y is -2. So everywhere in the Y column, we're going to put -2. That means we can pick any x's we want. So let's pick 1 negative, 0, 1 positive. The thing you want to be careful is you just have to stay under 10 or over -10 because you want to fit on the line. So -5, -2 would be right here. 0, -2 would be right here. And 5, -2 would be right here. So once again, we knew it was a special case, and now you can see that it is indeed the horizontal line that we predicted. And generally, the guideline is if you have more than one line on a coordinate plane, you're supposed to label them. So we'll go back and do that in just a second. So we did put these on both the Module 6 and Module 7 tests, these special cases. So you will need to either be able to look at the equation and goes through the y-axis at -2 and draw the line, or make your t-table and draw it from that. So to label them, we call this y equals -2. And to label the first one, it would be x equals 3. So those are our special cases, the vertical line and the horizontal line. And again, you can recognize them because their equation only contains one variable, where all the other equations we've done previous have had two variables, an x and a y. Okay, so let's go ahead and go to the next page, page 5 in the same packet. So for this one, we first have a warm-up problem. So let's go ahead and work on that, and then we'll move on to the new material. So this looks familiar, doesn't it? We had one just like this on the other page, or was it on the practice test? Yeah, on the practice test. So we have a fraction. We have an x and a y. So we know right away that it's not a horizontal or vertical line because it has both variables in it. So we need to decide what values we want to put in for x. So remember on the practice test on the warm-up earlier, we said we always want values that are divisible by the denominator. So things divisible by 3 would be 9, 6, 3, 0. So let's do the same thing we did on our warm-up. Let's use -6, -3, 0, 3, and 6. So we need to plug all these different values in for x and find out what y is. So y equals 2/3 times -6 plus 1. And then next we need to put -3 in for x, so that would be 2/3 times -3 plus 1. Then 0. Now we can drop the parentheses because it's not negative, so 2/3 times 0 plus 1. Then we'll do 3y equals 2/3 times 3 plus 1. And last, y equals, plug 6 in for x, so 2/3 times 6 plus 1. And then just like we did on the previous problem, let's pull out our calculator. I'm going to move it over a little bit so we can see the t-table, write the values. So type it in just like you see it. So 2 fraction bar 3 parentheses -6, close our parentheses, and then plus 1. So that gives us -3. Next, we're going to hit the up arrow. And we need to change that -6 to a -3. So after we hit the up arrow, we use the right arrow to type on top of the 6, make it a 3, and then hit enter, and it's -1. So it looks like we're going up by 2, doesn't it? Then hit the up arrow again. Next, we need to plug 0 in. And that means we have to delete the negative. So on top of the negative, hit DEL, delete, type 0, and then hit enter. That's 1. See the pattern forming? Add 2, add 2, add 2, add 2. So you can guess what the next ones are going to be. I always tell students plug them in anyway just to make sure you got everything right. This time our 0 needs to turn into 3. So that would be 3. And then last but not least, we need to turn that 3 into a 6. Hit your up arrow, key right, turn it into 6, and we get 5. And you can see the pattern stayed consistent, up 2, up 2, up 2, up 2. So our last step then is going to be to plot the 5 points and then connect them with a solid line with arrows on both ends. So -6 goes with -3, 1, 2, 3. -3 goes with -1. 0 with 1. And I can see my points are in a straight line because we said anything that's in the form y equals mx plus b is going to graph as a line. And you can see this is following the pattern. 3 goes with 3. And last 6 goes with 5. 1, 2, 3, 4, 5. So we have our 5 points plotted. So we use our straight edge to connect. And don't forget to put those arrows on both ends to show that it does go on forever. Okay, so let's write the definition of x and y intercept, and then I'm going to run out of time. Unfortunately, I bought a dock camera off Amazon, and it only records in 15-minute segments, so I have a little over a minute. I think I'll wait and do it on the next tape.